1, 3. You come out to multiply by column which is 1, negative 1. Again, negative 1, 3. You come now to multiply with, that is 5, that is 3. Again, you take now the second row which is 1 and 2. You multiply by 1, negative 1. Again, you take your solutions, that is, you write your solutions, and the A cross B will be equal to given by matrix A, which is negative 1, 3, 1 and 2, cross matrix B, which is given by 1, 5, negative 1 and 3. Now, how to multiply this one? I said that is, make sure that is you get all the rows will multiply by all columns in positive multipliers. I said that is be negative 1, 3, multiply by 1, negative 1. The same negative 1, 3, multiply by 5 and 3. The second row, I've got now 1 and 2. So just take 1 and 2, multiply by 1 and negative 1. The same 1 and 2, you multiply by 5 and 3. Therefore, multiply this one now. Negative 1 times 1 becomes negative 1. You add with 3 times negative 1 becomes negative 3. Negative 1 times 5 becomes negative 5. You add with 3 times 3 becomes 9. This is 1 times 1 becomes 1. You add with 2 times negative 1 becomes negative 2. And again, 1 times 5 is 5. You add with 2 times 3 becomes 36. Take your summations. So, negative 1 plus 3 becomes negative 4. Negative 5 plus 9 becomes 4. Negative 1 plus negative 2 becomes negative 1. And then 5 plus 6 becomes 11. This one will be the product of A matrix times B matrix will be this one. What about now B? A matrix B times a matrix A. That is a matrix B cross a matrix A. You start with our matrix B. Where is? Here it is. Will be 1, 5, negative 1, that will be 3. You multiply by a matrix A. Here it is. This is negative 1, 3, 1, that is 2. On this one, our row, the first row I've got now 1 and 5. You multiply by all columns in positive multipliers. So it's going to be multiplied by, here is by A, which is now being forgotten, one number being forgotten now, that is negative 1. Here it is. That is by A, which will have negative 1, that is 1. Again, 1, that is 5, will be multiplied by 3 and 2. The second row, I've got now negative 1, here the 3, will be multiplied by negative 1, that is 1. The same negative 1, that is 3, will be multiplied by that is 3, here is 2. How to multiply this one again? You take now 1 times negative 1 becomes negative 1. 1 times 5 becomes 5. You add it. Again will be 1 times 3 becomes 3. You add with 5 times 2 becomes what? Becomes 10. And then you come now, negative 1 times negative 1 becomes 1. You add with, here is 3 times 1 becomes 3. And then this one, negative 1 times 3 becomes negative 3. You add with 3 times 2 becomes, that is 6. On this one, you just take normal additions. So you add them, will be equal to, here is negative 1 plus 5 will be 4. 3 plus 10 will be 13. 3 plus 3 will be now 13. Then 1 plus 4 plus 3 will be equal to 4. And negative 3 plus 6 will be equal to 3. This is the result of B cross what? Cross A. Now, this one, we have seen that is A plus B is -1, -4, 4, -1, 11. B plus A is 4, 13, 4, then 3. How can you propose this one now? How can you make these conclusions? We say that when you come now to multiply a matrix K, let's say, times L will not equal to L times what? Times K. But in a rare case, can be equal. But normally are not equal. So in that case, we say that is multiplication of matrices is not that is commutative. Is not that is commutative. What do we mean? That is, when you come now to multiply a matrix A times B will not equal to matrix B times A. That is 3 plus 4 is equal to 3 plus 4 is 3 minus 4 is equal to -1, but not equal to 4 minus 3, which we're going to be equal to 1. This is what we call now commutative laws. That is, multiplications of matrix C is not commutative. Therefore, this one, but it may appear, that is, but in a very rare case, that is, it may be equal. If it will be the same, we say that is, a matrix is what? Is commutative. Otherwise, it is not commutative. So, after looking on this one now, let us now look for what we call now determinant of a matrix. Let us now talk about the determinant of a matrix.